integration involving inverse trig. So we're not actually going to be integrating inverse trig. That's an extension 2 thing. We really don't do that in extension 1, unless it's one of those questions where it's differentiate this, hence go and integrate this. So they give you a big clue. Basically, we're just going to look at going backwards from yesterday. So we know that if we have an integral like this, dx on the square root of a squared minus x squared, then it must have come from, well, actually there's 2 things it could have come from. It might have come from that inverse sine of x on a, but of course it might be the negative of inverse cos x on a. So remember, they both went to the same thing, which is one was positive, one was negative. So we actually have a choice as to which one we would use. And depending on the question, it becomes important which one we do choose. And we'll see that later on when we look at things like simple harmonic motion and things like that. It does become, well, it makes life a lot easier if you pick the right one. The other one then is just the inverse tan one, so dx on a squared plus x squared would go to that, but don't forget the one on a out the front. That's the big thing that's forgotten with these ones. With inverse tan, one on a is out the front. That's very limiting. Right, if you can create it in the form that we're used to seeing. So if you can create it into derivative over the square root of a squared minus the function squared, then that will be the inverse sine of the function over a, or the negative inverse cos. And for inverse tan, if you can create derivative on a squared plus the function squared, that will be, again, 1 on a is out the front, inverse tan of function x over a. Alright, well, we see a very basic one there. That is the x on a case. So I can just write that one. Okay, inverse sine of x on 2. I tend to go with the positives for something like this because I'm not doing anything with it. So it really doesn't matter which one I pick. Well, our one's inverse tan. As I say, don't forget the 1/3 out the front. Okay, let's do a definite one. Okay, well, that's a straightforward one as well. So that's just inverse sine x over root 2. Be careful with that. Remember, it's a squared minus x squared. So root 2. Sub in 1, sub in 0, we will see these numbers come up a lot because they're going to create the exact values. Now remember, you are subbing into an inverse sine function. Inverse sine has a particular domain and a particular range. So unlike when you're just saying, solving a trig equation and you say, well, it could be 30 and 60 and so on and so on and so on, there is only one answer you can get. And the inverse sine of 1 on root 2 is
4.
Excellent. Pi on 4. It is not 45 when we're dealing with this. And this now becomes real important. Because if you wrote down 45 thinking, well, that's all right, I'm using degrees, you are wrong. It is pi on 4. They are different numbers. Because remember, you are talking about an area under a curve or something like that. It has a value. Pi on 4 is 3.14, etc., divided by 4. That is a completely different number to 45. They are not the same thing. Calculus, trig, radians. Use radians. This is what I was talking about. You might get something like this where differentiate this, hence evaluate this. They're basically giving you a huge hint on the question, because look what happens when I differentiate inverse sine of e to the x. Well, the derivative would go on top over the square root of 1 minus the function square. Oh, look, it's exactly the same thing we're about to go and integrate. So if I had no idea how to differentiate that, I probably would just guess that, well, that integral is going to be the inverse sine of e to the x. Probably going to be that or some multiple of it. So when I integrate, I get inverse sine of e to the x, sub in the 0, sub in the minus log 2. E to the power of 0, well, that's straightforward. Anything to the power of 0 is, of course, 1, well, except 0 to the power of 0, of course. E to the minus log 2, bring the minus in, so that's the same as log of a half, then e to log cancels. We're now looking at inverse sine of a half. Inverse sine of 1, pi on 2. Inverse sine of a half, pi on 6, we get pi on 3. Okay. dx on the square root of 4 minus 9x squared. Well, this is the one where I'm going to say I want to create the derivative on top. But remember, that's the function squared. So it's 3x. I want the derivative of 3x on top. So I would like 3 on top. I have a third of that. But it's now in that form. So I can say inverse sine of the function 3x over, and the square root of 4 is, of course, 2. So I get a third inverse sine 3x on 2. That'll do us. Enjoy.